Good morning. Welcome to this first edition of the Trusted Summer School. This year, this edition will be online, will be not presential, not physical, but we will have a second edition next year that we will hope that will be presential. So let me share my short presentation to initiate and to introduce this summer school. It's just a very brief introduction presentation about what we want to achieve during this summer school and how we're going to organize these next days all together working in this trusted project. So as I already said, this is the first edition, but probably the first question is why to work in blockchain in the food system. And the reason to the reason for this trusted project and the reason to introduce blockchain in the food value chain is because we have three main issues in the food system, which are food safety, food fraud, and food traceability. Altogether, that constitute a concept that is called food integrity. And food integrity is a very important concept to generate trust and transparency in the food value chain. So all the stakeholders in the food value chain, to the consumers passing by the industry, by the transformers, need to be to know what is happen with food. So, and currently there are some limitations to have a real-time and global knowledge about what is happening with food through the food value chain. And there are four main reasons for this gap, for this lack of knowledge. The first is because the food value chain are not fully sensorized yet. So we need to introduce, we need to create this industry 4.0 where the sensors will extract, will harvest information from the food value chain. On the other hand, the sensors that we have are not always designed to work in IoT environment. So we have sensors of pressure, sensors of temperature that came from the past tradition in the food industry, but they are not connected. So this is as well a bottleneck. On the other hand, the information, the food value chain is often handwritten or written in Excel sheets are not really online or digitalized. So that is a added difficulty to provide this trust in the food value chain. And finally, the information integrated in the food value chain is not enough to guarantee its reliability. So we need to create a system that allow us with technologies acquire this level of trust by introducing concepts like physical and clonable function, crypto anchors, and trusted sensors. So this is the whole concept that we want to deal in this week. So at the end, our idea to introduce blockchain in the food value chain is to create this community of trust, to create this confidence about food production from the start, from the farm to the fork at the end of the consumers. So, and we are really convinced that blockchain is the perfect tool to use this disruption technology in industry, in the farmers, in the producers, and as well in the consumers, to guarantee this triangle of issues that we want to address during this summer school. So at the end of the day, in this summer school, we will talk about analytical methods. We will talk about sensors. We will talk about materials, managerial procedures. We will talk about software as well. So all together with the common denominator of blockchain. This is not new. So similar initiatives are ongoing, are implemented around the world, ongoing. So some of the most biggest companies, food companies, are already involved in implementing blockchain technology in their process. We are talking about Unilever, Nestle, Tyson, Walmart. So from producers to retailers, all of them are making efforts to introduce this concept in their operations. This is not for granted. This is because that represents first confidence, trust, but as well important. They think that will impact at the end of the day in reducing losses, in reducing non-conformities, in increasing safety in the food value chain. There are already commercial solutions, this Bureau Veritas solution, and with Wageningen that is really engaged in this technology from the beginning, and of course IBM that have as well commercial solutions for the food value chain. I think that we're going to learn deeply and to learn interesting things with this in this topic of blockchain and food value chain. The Trusted project is a project that is led by INL together with IBM and Wageningen. And the main objective of this project is to improve the capacity to learn from the best ones, partners, IBM and Wageningen, about blockchain in order to implement these technologies in our operations. So the idea is to learn about these three layers of the system. So the first layer is to identify what are the interesting case studies to implement food value chain, to develop the sensor that will extract information from this value chain, and finally to use this information in an integrated approach to create this digital layer based on blockchain. At the end of the day, during this week, we will work, we will talk about sensor, materials, devices, software, informatics, authenticity, concepts like safety, quality. So this is some of the topics that we will deal during this week. The technologies under each module are summarized here, but this is not probably important now. It's just to show that this week will be really broad in terms of different topics that we will touch. And this is because INL is developing sensors that we want to use these sensors in this context of blockchain. Next year, we hope that in the second edition, we will that will be presential. We hope physically. We will hope that we can show examples like this kind of lab on a chip devices that we are developing, sensors for food safety, solutions for food authenticity based on microfluidics or in DNA technologies, sensors for water contaminants, antennas or other sensors for traceability for embedded in food packaging. So of these technologies next year, you will have the opportunity to touch and to see physically. But this year we will try to avoid these inconvenient watermarks as well with these seminars and talks in this that will be delivered by our colleagues of INL, but as well Wageningen and IBM. This summer school is a part of the activities that are planned in the transit project. So the project is really ambitious regarding the learning activities. We have 3 talent programs, one for experienced researchers, the second one for early stage researchers, where this summer school is integrated. And as well, we have a program for managerial activities. We have different activities a part of these summer schools that all of you probably you can collaborate and participate. For example, we have this virtual cooperation platform. This platform is implemented in LinkedIn. So you are all of you invited to collaborate and to participate in the discussion that we are in this platform. This is an open platform for all of you. We want to create a big community based on this project of people that will be really interested in the implementation of blockchain technology in the food value chain. We have, of course, our website. Please visit as well our website, where you will have all the information of this project. Regarding the agenda for today and the next days, I will pass the presentation to Nuria, that will explain how this summer school will be carried out. Nuria, please.
Yes, hello everyone, and welcome to our summer school. My name is Nuria Barros, and I work at the Business and Strategic Relations Office at INL. So I will be presenting you the agenda now. Just one second, that I cannot really see where I am. Okay. So today we are doing the welcoming day and a little bit the basics of blockchain and food. This is just a summary of what we'll be seeing during this week. Then we have 3 core days, one for the application layer on Tuesday, Wednesday for the digital layer, and Thursday for the physical layer. And then Friday, it's a more sociable day, and we will have an invited speaker for the satellite event and a networking day. So just one second. Here you can see the agenda of today. So we will have a general intro from Gero, Dittmann, and Mireille from IBM and Wageningen. Then we will have, after a break of 30 minutes, we will have a session on careers. And then at 3, for those that are INLers, we will explain a little bit what will be the tutoring support that we offer in the summer school. Then here you have the agenda for the 3rd day on the application layer. you will see that each of these 3 core days dedicated to a layer, we have a scientific lecture. That means that this is a kind of different event in which we will have also invited, it will be open also to experienced researchers that from other institutions that can participate. And yeah, this is just for you to see an overview of what we will have in the following days. And this, as I said before, the DISH event with the Global Center for Food Safety and Quality, and then the social part, the networking event, where we will have a quiz with questions from each of the sessions that we will have. So stay attentive, because we will have a prize at the end with some food products, with some technology included. So yeah, the ones that will learn the most will be able to win it. And we will also have an INL virtual tour. Then some housekeeping. So don't be shy. This is the most important, because this is a virtual event, and we want to make it as much as possible as real as it will be in the physical. It will be presentially. We have just realized that you cannot show your cameras, and we would like to see you. So after the break at 11, we will send you another link, so that you can, so that it will be in a meeting mode, and you can put your camera too. But feel free to ask questions in the chat or after each of the sessions. Then keep your contribution short and to the point. And while you are not speaking, put your micro mute. And also to tell you that the presentations will be available after, well, we will try to update them every day, but we will put them in a repository. We already sent you a link through email, and I will try to put it in the chat too, so that you can, instead that you didn't see it. And that's it from my side for the moment. So now it will be Gero, Dittmann from IBM, and Mireille talking about why blockchain in the food area.
Nuria, probably just to reinforce the fantastic prize that we will have at the end of the summer school. Please participate, try to win this fantastic prize that for sure that you will enjoy.
Yeah, we can see you, Gero, and we can see the screen. We cannot hear you yet.
The unmute button is a difficult technology.
Now we hear you.
Okay, perfect. So thanks, Nuria. We'll kick off this day with some background on what blockchain is in the first place, and the particular applicability to the agri-food industry. The latter part is what Mireille will talk to you about in roughly half an hour or so. And I'll start with the introduction to blockchain in general. So what I now told you already is this slide. We'll start actually with a brief introduction of who Mireille and I are. And for that, I would pass it over to Mireille for now.
Yeah, sure. Yeah, nice to not see everyone yet, because we can't really see you as of yet. So I guess we're working on that. But nice to meet you all for this summer school project as part of the Trusted Project summer school program. My name is Mireille van Hilten, and I'm a researcher at Wageningen University and Research. you may wonder, university and research, how does that work? Well, we have two separate entities, actually, the university with many students from over 100 countries, all in the agri-food sector. And then we have a separate entity, which is our research institute, in which we have several other institutes. So I'm with Wageningen Economic Research, and we do social economical research. My specialty there is that I am involved in business informatics in our sector. So I deal with information management and data projects. And one of those topics is, of course, blockchain, which is one of my favorite topics that I'm passionate about, especially in the organic food chain. And I'll tell you a little bit more about that in one of the sessions on tomorrow's program. For now, I would like to add that Wageningen is indeed a high-ranked university each year, actually. So even last year, 2019, 2020, we keep scoring very high also for environmental friendly practices in our university. Our themes are on the on the bottom right side. So it's obviously sustainability and environmental issues. And again, for me, especially, and also my colleague Lan, who'll be introducing herself later on in the week, it's all about data and information management. So how can we use all these technologies to make sure that we can actually attain these goals around these sustainability themes? So that's not a very short introduction, but I hope you enjoyed it. Over to you, Gero.
Thank you, Mireille. We proceed to the left side of the slide, very surprisingly. So my name is Gero Dittmann. I'm a researcher at the IBM Research Lab in Zurich, Switzerland, where I'm working in the security research department on blockchain and also digital identity. This security research is just one department that we have here. The other departments are called Science and Technology, which is really operating wet labs, working on nanotechnology, has a long history in semiconductor technology. And I think that part of our lab has a significant shared interests with INL as well. We have a department that looks more into AI. Most recently has a long history in computer science of all sorts, business process automation and things like that. And we have a department that looks more into computer systems, storage, these kind of things. The Science and Technology department is very important for this lab because they brought us a number of prizes, including 2 Nobel Prizes back in the 80s for the scanning tunneling microscope and for high temperature superconductivity. More recently, my colleagues in the security research department are working on post-quantum computing. Post-quantum crypto, so keeping computers secure once quantum computing is more widely available. And actually, quantum computing is also a more recent but very important focus of our colleagues in the Science and Technology department. So enough about that. Let's dive into the technical content of this week. And you already heard from Lorenzo that blockchain is a core area of the collaboration that the 3 institutes here have. And I know that we've had a session in a previous workshop that we organized, probably not with all of you in the audience here, where Mireille already gave a very good more formal introduction of blockchains. But it's always good to hear things more than once. They can really settle, and I'll try to approach it from a more intuitive angle today. So maybe we find something that works for everyone. So what's the problem that we're trying to solve with blockchain in a business context in particular? So this is a rough concept of how businesses interoperate. Today, even in the digital world, where you have a large number of companies that share a business process. They all provide services for to achieve something bigger together. And typically this works still today by establishing a lot of point-to-point links between each of those partner couples, if you will, where they exchange data, and each of those partners maintains their own record of the state of the world or the state of the shared business process. Where are we? Who has done what yet? And who has signed off on which approvals, right? And the problem with these distributed records is that they tend to diverge sooner or later, because somehow the interpretation of the business rules is different, or misunderstandings or something along those lines, right? So sooner or later there are conflicts between the views of the partners, and that tends to put sand into the gears, and is always costly to resolve. And this is where blockchain comes in. So we can exploit blockchain technology to automatically share these records and make sure that the copy that every partner holds is exactly identical. We can still call it an agreed upon state. So a state that everybody agrees this is where we are, because the blockchain also comes with what is known as contracts, right? So as pre-agreed business rules that everybody has agreed on at the beginning, which determine how the state can be changed, right? So everybody agrees these are the rules how to change the state, and this is the current state that is reliably distributed to every partner. And on this basis, this is a foundation on which we can automate those business processes. They are permissioned, right? So it's clear who's allowed to or required to give which approval or to contribute which data, and it is auditable because of these properties of a blockchain of being immutable. So you can only ever write to a blockchain and never overwrite something, right? To summarize that in a slightly different way, what are the main properties of a blockchain? At the core, there's the shared ledger that is immutable. It cannot be changed once it's been written to. It can only be appended ever, right, is what that means. It is distributed, so everybody is guaranteed to have the same data in it. Every copy is the same. And so it's shared throughout this business network. Then we have the smart contract functionality, which allows to add programmable logic to the system. And this logic typically implements the business rules that everyone in the network has agreed to at the beginning. And they use the shared ledger as kind of a transaction database. Then we have security, because the transactions that modify the content of the shared ledger are authenticated, right? So I mean, there's some nuance here. As you maybe notice, I'm focusing really more on the business process automation kind of blockchains, but we'll see a little bit more about that later. So the transactions are authenticated. Everybody who wants to change the data needs first to authenticate with the system, and needs to be authorized to perform this particular action. And all this is basically the foundation why everyone trusts the blockchain, because they agree and understand and agree to how it is being managed in this shared way. What does this look like from a user perspective? Well, a user doesn't really notice much difference between interacting with a system that's built on a blockchain compared to a system that's built on a traditional, more centralized database. As a user, you would typically interact with it via a web page, as you see here, on the right-hand side or via a mobile app. And the qualitative difference to everyone involved is the trust that the data can be relied upon and changed only based on these agreements throughout the network, right? So the trust is what the backend provides. The front end looks not much different from traditional systems. Now, to start with a very simple example of what an application in such a blockchain network could look like, let's look at a taxi dispatcher, right? That is a common, traditionally centralized operation. You have a number of taxis that are looking for rides or for passengers, and you have a set of passengers that are looking for a taxi. And then you have a so far centralized dispatcher in the middle that intermediates between those parties and tries to find a good match between a taxi that's maybe close to a passenger that is asking for one. So the actors we have are the drivers that request a fare and announce their current location. We have the passengers that request a ride and with their current location. And we have a dispatcher that assigns the request to the closest match, then notifies both parties involved. And if there's no match right now, they might even queue either side, right? Maybe there's too many more taxis than rides available, or the other way around. And the dispatcher, this centralized party in this use case here, that is what we can replace with a blockchain in a decentralized way, right? Where everybody involved, so the taxi drivers and the passengers, can participate in running this thing and making sure that the assignment is fair. The parties would authenticate to the network using cryptographic certificates that identify which role they participate with in the network. So the certificate identifies a party either as a driver or as a passenger. And then the chain code, or that's just a different word for smart contract. So the smart contract detects which role this entity would participate or holds, and that then determines the functions that the party can call, right? Either hail a ride or request a passenger, for instance. And throughout the operation, so the chain code or the smart contract would then manage these queues and find the matches and announce them to the involved parties, while always storing the current state of the system on the ledger, right? So that everybody can see that there's a driver driving a passenger to some place, which means that everybody can verify also the fairness of the system. And these states can also be searched like in a traditional database, which helps with some sort of process automation. And what we've seen here is a classical use case of disintermediation, right? We've replaced a central party that everybody in the network is required to trust in order to participate. We've replaced this central party with a decentralized system that is sharedly operated by the stakeholders. Larger application cases that already go a bit more towards the food industry are, for instance, trade logistics. You can imagine that in general, supply chain applications with all the parties they involve are one of the killer applications for blockchain. This year is an example of an IBM started network called TradeLens, which also aims to make this entire supply chain operation more efficient, because so far this industry isn't even very much digitalized, and there are still paper documents sent around along with the containers, but on different routes, which of course inevitably leads to some documents being lost. And that can mean that that the container is stuck in port sometimes for more than a month, right? And digitalizing that on a blockchain, which means that all these different parties that don't necessarily trust each other can participate in the operation of the digital infrastructure, that has the potential to make this a lot more efficient and prevent these lost documents and this time lost. Another example is IBM Food Trust, which tracks the provenance of food, so that if there's a problem with maybe contamination, and there have been cases in the past, we can speed up the time it takes to identify all the shipments, the partial shipments that are affected, to very quickly remove contaminated food from shelves. More generally, what makes a good blockchain use case, right? What are the important features? So this question is rather important because at least at the beginning of the hype cycle, you can imagine that many people just wanted a blockchain solution because it was the new kid on the block, it was hip. But I think there's no point pushing blockchain into use cases that don't really need them. That just leads to a suboptimal overall solution. So what makes a good use case? First of all, a blockchain use case always has a well-defined business network, right? It's clear what the industry is, who the potential participants in this blockchain network is, and it is important to convene a network or a community, a consortium that is big enough to really get a blockchain network off the ground. It's not something that anyone alone would want to start. And this community is defined by caring about common assets and often also sharing business processes. And another important question is if there's an audit trail. So or more to summarize it a bit, the question is there shared data that everybody has a critical interest in making sure it's correct, right? This could be an audit trail that's required by regulators. It could be data whose provenance is critical, and that could be coming from any of the members of the network. Or another application case is also reporting, right? Shared reporting on which there needs to be a consensus. More questions, is there a need for jointly managing data? Are there multiple parties that could change data, and they all need to agree that this is these are the correct values? Might the involved parties have conflicting interests? Or maybe to extend that a little, are they worried about a single party controlling the entire thing, right? Then the decentralization really provides value. And it's important that the community can agree on the rules by which they want to manage the data. So that basically they have a set of rules that can be implemented in a smart contract. If you abstract that a little, the fundamental use case types are either automating shared business processes that involve multiple companies or parties of some sort that are independent of each other, right? So you don't need a blockchain typically if you want to automate business processes within an enterprise, even if it's a global one. There typically is an IT infrastructure or department that everybody trusts. But as soon as you want to automate business processes across multiple parties, then a blockchain really provides value by allowing them, by giving them this shared trusted data foundation, right? Then another use case would be assets that are jointly managed by all stakeholders. This goes more in the direction of digital assets, and maybe in the extreme case, or also the case that started it all into the direction of cryptocurrencies, where everybody participating in a cryptocurrency network has an interest in the currency being managed properly, right? And obviously that is a killer application for blockchains. And then just could be as simple as joint record keeping, right? If there's an industry that needs to agree on some records that an auditor wants to see, that is a very simple but very effective use case for a blockchain. There's also, of course, pros and cons to a blockchain. I think you already maybe have a feel now for a few of the advantages of blockchains, mostly compared to centralized systems and databases. So the big property is that blockchains are immutable. Right, no party can change the values that have been written to the blockchain once. That also makes it perfectly auditable, the data on the blockchain. There's no trust required in a central party, so that's this disintermediation that people talk about a lot. That also means that there's no central system that manages all the data that would be an interesting point of attack for hackers. Right, there's no single system that a hacker can take over and then control the blockchain, but they would almost have to attack all the participants at the same time. The distribution also provides high availability, right? If one node in the blockchain goes down, the rest of the blockchain can still function nicely. That also makes it highly scalable for read operations because every partner has a copy of the current state of the data. Everybody can serve read operations in parallel without affecting each other. And then one additional aspect of blockchains that I think we're still only beginning to explore are the token ecosystems. So this token concept of a token representing an asset that can be held or owned by a party on the blockchain, and that is used not just for managing cryptocurrencies and maybe also fiat currencies, but all sorts of digital assets. That is a very powerful abstraction that has a lot of research and innovation going into it right now. But of course, blockchains also have cons, disadvantages. They're by and large unsuitable for large amounts of data. So ideally, the processes that are being automated would require only small amounts of data that represent the state of the process. If you want to share large documents, videos, I don't know, gigabytes of data, the more reasonable approach seems to be to maybe store fingerprints of those data on the blockchain to ensure they cannot be modified without anybody noticing, but the data themselves more and more tend to be stored off-chain in databases where they can be retrieved. So then the blockchain is only used to make sure documents are not modified without agreement. The blockchains also have a significant overhead in the latency for writes to the ledger, and of course also in storage, because we have all those copies, right? Every copy holds the entire content of the blockchain, so every node you add also adds to the overall storage of the system. And what is also rather important to understand is that no one should try to write personal data to a blockchain, because the immutability that is on the one hand an advantage makes it, on the other hand, makes it impossible to implement privacy regulations like the right to erasure, right? Once personal data has been written to the blockchain, it will stay there, and that is a problem. There are different flavors of blockchain, and again, this is not a very formal definition of what those concepts mean. For that, I would encourage you to go back to Mireille's presentation from some time ago. But just roughly, the two main flavors of blockchains are, on the one hand, unpermissioned public ledgers. So unpermissioned means anybody can start interacting with it and kind of create their identity on that blockchain. And public means that everybody can also get a copy of it and explore that. And that is how Bitcoin started, right? Bitcoin, famously the cryptocurrency that started the entire blockchain field. One disadvantage of those blockchain networks is that so far they basically still all run on the famous proof of work consensus algorithm, which is very compute intensive, and that is, you probably heard, what makes these kind of networks so energy intensive, right? They consume a lot of energy. The transactions are viewable by anyone, of course. Everybody can have a copy of the ledger, but the participant identity is more difficult to control. It says here that is not necessarily a disadvantage, right? Many people appreciate the anonymity or pseudonymity that is provided by those networks, even though there are limits to how pseudonymous this really is. As people increasingly find out, but that's the one side of the community, if you will, and the other side is the permissioned and also private blockchains. These are blockchains where only the consortium members, the well-defined consortium members, hold copies. That's what makes them private, copies of the ledger, and permissioned because to initiate operations on the blockchain requires parties to be authenticated and also authorized to do that according to the smart contract, right? So they prioritize identity over anonymity. They use endorsements, which means transactions require the approval of a defined set of authorities rather than the proof of work approach. Which comes, of course, again with the disadvantage that you need some authorities that people trust for these interactions, right? Depending on the application, you already see, right? One is an advantage, the other one is a disadvantage. It's really more different properties than advantages overall. So this is more about business assets than cryptocurrencies. And while the network members are known, the transactions can be secret. There's quite a number of approaches that people explore for that. And one example of these ledgers would be Hyperledger Fabric, which is the focus of the research in our lab. And sometimes there are also mixes or combinations of these properties. For instance, in the decentralized identity space, which is an emerging variant of digital identity, people tend to use public ledgers that are permissioned, right? So meaning everybody can read these ledgers in order to verify identities, but the writing to the ledger is permissioned, so that the content remains reliable or tied to certain parties that are authorized and that people trust with those identities. There's more differences between blockchains. Most blockchains do what is called post-order execution. That's what you see at the top. So one important function of a blockchain on a more technical level is the ordering of transactions, right? It's not just important that every party in the blockchain agrees on what legitimate transactions and modifications to the ledger are, but they also need to agree on the order in which those transactions are executed. Because the order, if they wouldn't, right, that might lead to different results and then ultimately different data on the blockchain. So the most common architecture is that the parties in a blockchain first agree on the order of submitted transactions, and then these transactions are just kind of distributed to all parties, to all nodes in the blockchain, and each then executes these transactions in a well-defined way, so that it is guaranteed that each node arrives at the same result of that execution, right? Which also means that every party needs to do the execution, right? Whereas the Hyperledger Fabric blockchain that we are focusing on first does the execution, and the execution is only done by these so-called endorsers. Those are the parties that are required to approve the transactions, right? So they first look whether the parties that submitted these transactions are authorized to initiate this functionality. Then the endorsers execute these functions, and that might only be a handful of parties. Then they submit the results of the execution to the ordering service. And the ordering service then really makes sure that the transactions are in an order that such that the first transaction doesn't modify, no, the other way around, that the first execution, the first transaction that's being submitted doesn't need an input that is modified by a second transaction, right? Because that would then lead to read-write conflicts. So that's what the orderers do, and then only the results are distributed to all nodes in the blockchain in the order determined by the ordering consensus, and that then also makes sure that everybody ends up with the same data, and each node then only makes sure that the endorsements are correct, right? That the authorized parties have endorsed the transactions. Now a bit more about Hyperledger Fabric. The Hyperledger is a consortium or a community maintained by the Linux Foundation. So it's an open source kind of project or umbrella project that maintains quite a number of different blockchain technologies. I think it still is the fastest growing project in the history of the Linux Foundation. It has, as you will see, members from many different or from all sorts of different industries. In fact, this year, I know it's very small, but that's because there are so many. This is an overview of the current members of the Hyperledger project. There are 3 tiers, right? The premier members are on the top, and of course I'm happy that IBM is one of those. There are general members and associate members, and you see all sorts of tech companies, telecommunication companies, financial companies, all sorts of different industries you will find represented there. And one reason why IBM is indeed a premier member is because the foundation of the most widely used blockchain in the Hyperledger project, which is Hyperledger Fabric, part of the technology originates actually in our lab in Zurich. So we built a first version of a blockchain, and after some time contributed that to the Hyperledger project, together and merged that with other efforts that existed there. So this is still the core of Hyperledger Fabric. Here's an overview of all the projects that are hosted by the Hyperledger under the Hyperledger umbrella. You see a number of different ledgers. Fabric here in the center. Hyperledger Indy is an example of a decentralized identity ledger, probably the most widely used at this point from the decentralized identity community, which is also known as self-sovereign identity. There are other general purpose blockchains. Sawtooth, for instance, was contributed by Intel. Some are Ethereum compatible. And there are some libraries and some tools like Hyperledger Explorer, which allows you to monitor the state of the current state of a blockchain like Fabric. A brief idea of our involvement with Hyperledger. So in 2015, some of my colleagues in Zurich started working on their first prototype of a blockchain. IBM became a member of, or a founding member of Hyperledger in early 2016 already. Then released and contributed part of the foundation of Hyperledger Fabric. And then over the years, IBM released several versions of Fabric. And the most recent innovations there are Token SDK, which added the token abstraction to Fabric, and also a Fabric Smart Client, which is an interesting new way on the application level to work with Fabric more, which allows peers or smaller groups within a blockchain consortium to operate with each other in a more private way and then publish the end result of this interaction to the global ledger. That is basically the end of the overview I wanted to give, just as a structure for this week, a layer that we in this project here in TrustEat operate in. We view the world, and I think Lorenzo also mentioned this before, as in 3 layers. We have the digital layer at the bottom. That is where the blockchain that I just talked about belongs to. Maybe also some IoT aspects, how to integrate IoT into a larger system. We have the physical layer that is worried about sensors, but also about authenticity of physical goods, and about identification, which is represented by the QR code here. And then on top of that, the part that really creates value for the stakeholders in an industry is the application area, where you see all the players that want to interact and need solutions overall. And with that, I would pass it to Mireille.
Thank you, Gero, and thank you for your presentation on blockchain. I liked it a lot. I have some questions, but not for now, maybe. So let me share my screen. And to everybody who's listening, I think and watching, you are allowed to post a question in the chat. I haven't seen any questions yet, but feel free to do so. Right. I think you're looking at my screen now. Thanks, Gero. Right, so Gero has talked about what blockchain is, and we haven't been talking about blockchain specifically in our industry yet, which is basically why we're here. I think to compare it with other industries from time to time is quite interesting, and we need to do so because the agri-food sector is not a front runner in adopting blockchain technology. So the example that Gero gave us about Bitcoin is a very well-known example, and the financial sector is very much ahead. But the question of this session is why blockchain in the food industry? So I'll be talking a little bit more about that. Yeah, we won't be able to provide the answer just now in the next 20 minutes or so, because I think it's a question that we need to keep in the back of our minds throughout the week, actually, or maybe throughout the entire project. We see advantages of applying blockchain in agri-food, but we're really in the middle of it, right? So it's not a question that we have the final answer to, I think. But at least my view on it today is, first, let's break up a little bit what we call the food industry, because that's also changing as we go along. If we look at the food industry as a very linear process, which is one of the things I spend a lot of time on process improvement and analyzing processes. Yeah, we start at the food side or the production side, the farmer side, and end up at the consumer side, who is buying products and interested more and more in where products come from. So yeah, it's kind of a clear process, right? It goes from left to right, and each step has also information that flows along. But maybe that's not really the only perspective that we need here, because it seems easy to manage, even though value change in the food supply chains are sometimes very long. yeah, it seems easy enough to manage when it's very linear, but often it's actually not. So a chain of organizations that is growing and producing and packaging and shipping and selling food to consumers and business, yeah, that's what it can be like, but often it's much more complex, and we have so many players involved in these supply chains. So it's cross-border, it's multi-industry, and it goes beyond the borders of one single organization, which is, of course, already one reason to be thinking about how to apply blockchain. So moving away from that linear view, more maybe to a societal view is, yeah, we talk about farm to fork. So the whole chain is everybody involved. And we also call that from pitchfork to plate, from farm to table. There are many, many ways to talk about it, from grapes to a glass of wine, maybe is another one. But we need to also include the input suppliers and any other type of organization that is involved. So we put more emphasis on consumer health. And we also see that if we make this whole chain view, if we use this view, this perspective, we can actually connect farmers and consumers and kind of make it into a circle, make it round instead of just linear. So that's maybe another way to look at the food industry. Another way is to look at it as a circular economy. Again, moving away from the chain and linear perspective, but this is really more about reuse of organic resources, minimizing waste, and also connecting to other sectors. So not just keeping it within agriculture and food, but connecting it to maybe the health sector. And the aim of all of this is, of course, a safer food system, and that we do not use a lot of contaminants and we minimize waste. So I guess another way to look at what we call the food industry. So then why blockchain, right? We're not at that point yet. I want to share a video with you from one of the other institutes at Wageningen, who makes the link a little bit, which connects the circular economy to our food sector. So you should be hearing the sound once the video starts loading. And please let me know if there are any issues. Here we go.
Each year, the food industry wastes $2 billion worth of food. But why waste it when we can use it? Wageningen Food and Bio-Based Research believes in an economy in which all agri-food residues are used to create value-added products. We provide the expertise and technology to extract maximum value from your side streams by creating new food products. The parts of the side stream that are not fit for consumption are mostly used as sustainable raw materials for bio-based products. And that's how we distinguish ourselves, by linking food with non-food supply chains. Take the sugar beet, for example. Most of the beet pulp residue is used as animal feed or raw material for biogas. Our research has shown that its residues can also be used for commercially interesting food and non-food applications, like components for paint, food fibers, drilling fluids, or cement. We're even looking at how to produce a plastic bottle totally made out of beet pulp residue. Interested? We provide a number of services which can help you transform your idea into a marketable product. We can assist you with process and product design, data management, monitoring and analysis, and supply chain management, but also with consumer understanding, policy and regulatory advice, and creating new business models. Let's make waste history. Create more value out of your agri-food side streams today.
Well, you don't want to watch it again. So yeah, that's just a nice video from our colleagues at Food and Bio-Based Research, which is another institute entirely, but we do projects across institutes with our colleagues there. But then, yeah, that's another way to see the food industry, right? And blockchain in respect to circular economy. We haven't talked about that a lot in our previous sessions, but my colleague Lon and I are also working on that topic as well. So that's the food industry as it's changing, and we're all involved in that. What are the current demands from this food industry? Let's just call it agri-food industry or agri-food, and not. But again, I mean all these types of ways to look at it, right? So supply chain linear is a view. We can take that view when we need it. We can look at it in a more circular way as well. So the demands are quite huge. And if we look at food supply chain efficiency and safety, there's a lot of focus on healthier food, well-being, but also on reducing the costs in the food supply chain, because each step and in each lengthening of the chain adds cost to it, which translates into pricing or changes in pricing for consumers, and also for payment to farmers or other types of producers. Then we have compliance. So all these organizations that work together in the agri-food industry, they need to comply to many, many, many regulations. Some of us are involved in that. And that's where we often see a role also for blockchain. Improving traceability, which is, it can be driven also from compliance, but it can also be driven from the consumer expectations or wanting to know more information about the provenance of a product or the location of a product. So all of those will lead to a safer food system and a more efficient food supply chain. And then we have all sorts of sustainability and resilience topics. We need to meet the food demands for a growing population. We've seen the resilience that is required since the global pandemic for COVID-19. So is the food system resilient enough to deal with these changing events, really disruptive events in our health system? And of course, food system needs to be environmental friendly, which we have many sub-themes there, from pollution to efficient use of water, etc. So there's a lot of pull factors on this slide, which are very, very important and make it quite complex. And the third one is a fair and inclusive and transparent food system. So we tend to forget the small scale food producers that are all over the world, especially in continents as Africa and India, where a lot of our food comes from. So they all need to stay involved and be able to keep their businesses running. And we also see that sometimes we refer to it as a digital divide. So is everybody able to come along in this current food system that we're in, or do we need to create more access to certain groups of actors or people in our food system? So those are some of these pull factors. We can also look later into the push factors. So technology can be a push to want to change the food system and adopt new technologies to be able to reach these goals, right? Okay. And then looking at it again from a food supply chain, a very linear perspective where all these organizations pass food on to the next step. There are some challenges if we look at maybe a system perspective. There's a lack of transparency. So all these organizations have to share data, which sometimes is unavailable. As Gero said, still a lot of paperwork throughout the logistical process, but also on the producer side. So data is maybe not even available. There is still a lot of manual labor and a lot of manual paperwork. The different systems that are used within a food supply chain often do not communicate with each other. So there's a lot of interoperability issues there, not only between systems, but also between devices or sensors, machines and systems. So data connections are really key in the sense of Internet of Things and blockchain connected together. So, and then the result is that we have limited information on the traceability of a product. Okay, so those are again some of the challenges. So, and if we look at the technological push, we see that we really want to ensure the immutability, what Gero also talked about already, between a product and a process. So how is a food product going through the food supply chain? And can we really make sure that this is validated information, and which is something that we can do with blockchain. And that way we can ensure maybe the future of food safety, create greater efficiency for the trading and the finance side. And this financial side of agricultural value chain is also very interesting, because payments, providing insurance, loans for farmers, or any other derivatives can also be supported with blockchain technology. And that way we can get a smarter and more accessible data and market information as well. So hopefully with blockchain and other technologies, we'll create a better future for agricultural supply chains. And in our sessions tomorrow, actually, we'll be talking a little bit more about that as well. So there's one on the application area tomorrow morning, and there's another one in the afternoon, developing a blockchain application for successful use case. We'll be talking a little bit about that as well. So assuming that everything that I told you so far and Gero told you about blockchain is true, so blockchain can help achieve these goals. How do we get there? Which is also the session of tomorrow afternoon, developing a blockchain application. How do we get the food chain ready for blockchain? So BCT is blockchain technology. It is really not a very, it's quite complex, because we have all these partners in the food supply chain. We have all these organizations and these systems. So it's quite important to analyze the current situation that we're in. You have to design a preliminary version of a system. We call it a proof of concept. We may call it different as well, like a prototype. We'll come back to that tomorrow as well. And we also continuously have to check and monitor the implementation. So what we, in our experience at Wageningen, what we see is we first start with a scan, a blockchain scan. We can see what is the status of the IT systems, which actors are in the community, which is something that Gero also said, right? For a successful use case, you need to have this community of all these organizations together. And is that blockchain proof? Do we actually need blockchain? Or maybe we can better set up a centralized system and make it work like that. So blockchain is not always the answer. And then move to a proof of concept. And the organizational aspects are very key here as well. You can set up the system, but you really need to test it in the live environment where everybody uses the app or the interface, and where you can really see how the data flows through. Also, the technical aspects, of course, are important when you're testing, and then a roadmap to the actual implementation is key as well. And a way to support the implementation is to constantly do assessments on the implication. And then there's also recommendations, and you also have to develop the ecosystem. Something that we're going to talk more to you about tomorrow afternoon as well, my colleague Lan van Wassenaer and myself. So what do we mean by an ecosystem? A blockchain ecosystem, in short, is made up of not only the partners in the supply chain, but also maybe an IT company that helps you out with specific blockchain services or development services, or we'll talk to you a little bit more about that tomorrow, but it's the entire ecosystem that's involved. So it's it's complex in that sense as well. It's a project that's all around IT, connecting it to this supply chain. Okay, so some examples of blockchain in agriculture, and I'm going to go over it a little quickly. I have only 5 minutes left. So we see kind of 4 different types of applications: traceability, the optimization of food supply chain, and crop insurance. So these are some of the financial products I was talking about earlier, and it can also be more aimed on the transaction level. So there are quite some applications in the agri-food domain, which we are constantly monitoring and mapping. So they're very diverse. Traceability is actually my favorite topic. So where does the food come from? What's the origin? Have all, for example, organic certifications have been met? So really helping the consumers to verify the journey of the product. Optimization is really more about the process, going through each operator, if you like, throughout the supply chain process. And insurance, more about the financial side, providing more visibility across the supply chain. And the transactions more could be more on the farmer side, helping farmers to sell the commodities, lowering transaction fees maybe. So it's more about the pricing and the transaction and the trade. All right, so we have some of the logos here. You can feel free to look into, for example, TE Food or AgriLedger on the bottom right corner. And we have a whole list of examples like these that we'll come back to. Let me talk a little bit more about 5 examples that I know a little bit better myself. So there is one that's in the Netherlands, which is Fair Food. So they trace nutmeg all the way through the supply chain. And maybe in one of the other sessions, when I have more time, I can show you their solution online. And they also provide information on the individual farmer that produces the nutmeg. And as it flows through the supply chain process all the way to the consumer that buys it in the supermarket, he or she can scan the code and then provide a little bit of information themselves. So this is really a nice tool to look at traceability. There's another example that I researched myself in the fair trade and organic food chain, which is an example of an organization that did not end up using blockchain. So they researched it and then said, well, we won't use blockchain as of yet. We're not too interested in the location of the product or the flow through the supply chain, but we really want to provide information on where the product comes from, our fisheries. So the fishermen provide information on their website. So they ended up not using blockchain, which is also something that Gero talked about. You don't always need blockchain. Another one is a large retailer in the Netherlands that provides a QR code on their orange juice packages. You can scan it and then you can see exactly where it comes from. And the oranges are Rainforest Alliance oranges coming from Brazil. So it's kind of similar to the first solution, except the first solution is open source, available to all types of food chains that want to food value chain that wants to collectively hop onto this system. They can use it. I think it's even a basic free subscription mode, if you like, and as you want to move on and use more functionality, you have to pay more. So it's the 2 types of blockchains that Gero was talking about, the more public one, unpermissioned one. It's more that one, and the retailer one with the orange juice is really a private one that opens up the viewing of the data to the consumer. So, but no, the consumers are not able to write on that blockchain or store data. Then there was another project I researched, which involved an NGO, and they traced organic rice throughout the value chain. They had a successful proof of concept, but ended up not investing in this solution for other reasons. So it can be a proven situation, a proven proof of concept, something that works, but there can be other reasons for not wanting to continue it, maybe other investment themes or something like that. And then, of course, the IBM food trust platform that Gero already talked about. So I won't talk about that very much, but Carrefour is one of the well-known retail organizations that uses it, and they're adding products, right? So every time a new value chain is added to the food trust platform, which is the same for the Dutch retailer in the middle. By now, they're also tracing eggs and other products. So we do see more and more applications in agri-food. And I'm kind of looking at the time because Nuria had asked me to keep it a little shorter to make some room for presentations. So I'll go over this one quickly. And I know this slide is actually coming back in 1 or 2 other sessions. So we'll talk about it some more. But we do see that the drivers for blockchain use cases in agri-food are very different. It can either be farmer-centric, it can be more focusing on supply chain management and optimization, or on the consumer side. So the Fair Food logo on the right here is the one that provides the nutmeg solution that I just talked about. So it's really about consumer information. It's also on the left, however, because it's also about fair payment for farmers. So it can be both. Okay, so we have a lot of agri-food opportunities or problems addressed. We like to categorize these, and so the relevant topics go from transparency all the way to efficiency again. And it can either be focusing on the lack of trust that Gero also pointed out, but it can also sometimes be like new value creation or the distribution. I'll let you look over this slide after the session, because it's just a collection of items. One more thing that I would like to add, specifically for the organic food chain, when we talk about traceability, is what I think is that there's also a trade-off, right, between the level of or the amount of traceability that is desired. So the more information you want to share, so I call that the line of transparency, the more you share, the higher the external traceability is. So you share organic and origin data and farmer data. And the internal traceability is more about the logistics side of it and the following of the product. So there's this trade-off. The more you share, the more careful the decisions are about what types of data do you want to share. Because, for example, pricing or the location of an individual farmer, those are sensitive data elements that not all organizations wish to share. So this trade-off is quite interesting once you start talking about what you actually want to trace and share, what kind of information. All right, and then my final slide is that I just wanted to mention that the example FloriChain is the one that we'll go into in more detail tomorrow afternoon with our colleague Koos van der Meij at Wageningen, which is one of the examples that we're working on at Wageningen. Is in the horticulture sector. So it's not just farming and food products, it can also be flowers and plants. Right, then one short summary slide. I hope that you now have an idea of a first idea of why blockchain is applicable to the food industry. And if you have any questions, please put them on the chat or send us an email or keep them for one of the later sessions where we can actually see each other by video. And I want to thank Gero, and that's it for now from my side. Nuria, are you here?
Yeah, many thanks, Mireille. Very nice presentation with the samples. So I don't know if anyone has any question. You can raise your hand, and I think we can open your mic to ask them. or just write them in the chat.
I have a question for both, for Gero and Mireille. So from an economic point of view, what is the expectation of the implementation of BCT blockchain technology in the food industry for the next year? So in other words, do you think that this is a hype or this is a real trend in the market for the next year?
I think it's no longer a hype, but that's my take on it. Maybe Gero has a little bit more detailed on it.
Certainly not more wisdom, but I have my take on it. My take on it is indeed that I think the hype is over. The hype was characterized by ignoring what both Mireille and I had on our slides, the points when a use case is not actually a good use case for a blockchain. And I think it took the past few years to understand blockchain technology well enough to really differentiate the strong use cases from the not so strong ones. But for the strong ones, I believe this is a building block that has been missing in IT infrastructure in general, making it finally possible to run these business processes involving multiple businesses and even entire industries. I believe that is here to stay.
So there is room for next developments in the next years.
Absolutely.
This combination.
Absolutely. I think we've only just started really to explore the use cases and to find the right ones, and I think there are many more. The tokenization that I mentioned on my slides too, that is still early days, and there will be a lot more innovation in that space.
Yeah, I think that this is a very interesting message for our attendees, for the people that is in the summer school, that probably they are thinking how to orientate their career in the future. So there is room in this topic to develop a career.
I think so. So I think so far research has focused on the core technology, and I think there's an awful lot of work to be done on an application level, right? And with the food industry being one very rich ground for use cases. Yeah.
Thank you.
Any other questions? Yeah, there is here one from Marta Prado in the chat.
Oh yeah, the line of transparency.
Yeah, she's saying, I found very interesting this line of transparency that you mentioned in your presentation, since we are dealing with transparency, and this is a very important point, but at the same time, data protection is very important. Mm-hmm. How do you think we can find a balance on this?
Yeah, I think technology also provides solutions there. So Gero can probably talk more about the sovereign, self-sovereign identity is one example, I think. But what I saw in the use cases, the 5 that I presented, is that the partners of the supply chain together found solutions for this. So in the case, for example, of an individual location, let's say a geolocation of a farmer that maybe the farmer doesn't want to share because the buyer or the exporter then knows who the supplier is, right? So it can lead to all sorts of competitive issues. In that case, they decided not to share the actual data, but to make it more like it comes from this region. So they make it a little bit more vague, or they, instead of, for example, farmer salaries, they would use ranges. So a farmer makes anywhere between $5 and $15, for example, is different than sharing the actual data. So that's a solution more on the practical side. And from the technology side, I think there are also many solutions available. So I think we can find a balance. And at the same time, I see that there's a development going on where the sharing of data is becoming more and more normal and accepted. not personal data, but anonymized data. If you compare it to other industries where we have the huge Googles and the huge Facebooks of this world, I think there it's more accepted and more normal that we have data on everything and then we use it and then we capitalize on that. And in agri-food, it's still a little early days. So that I think Gero said that well, and the same goes for finding this balance. I think there'll be solutions on their way. Maybe something to add, Gero? No, putting you on the spot again, sorry. So I hope that's an answer to your question, Marta.
Okay, thank you. So I'm afraid we don't have time for more questions now. One important note before going to the break, as we want to see you so that you can have your cameras on, we are going to send you a new link for the next sessions. So we are putting it here in the chat. I think you already have it here. So we will be starting at 11 with a session on careers with Patrick Ruch from IBM talking on hypertaste and the careers at IBM. Then also with Lan talking about blockchain, the human capital agenda in the Netherlands. And then we will have a little panel session with Mireille, also Marta, Prado, Patrick and Lan talking about different skills needed for blockchain. Also, if you have, I mean, if we can connect just a little bit earlier, like 10 to 12, if you are not in Portugal, or 10 to 11 if you are in Portugal, then this way we can put the cameras and just briefly introduce ourselves, all the participants, so that we can know who we are. So hopefully seeing you back at 10 to 11 and have a nice break.
Yeah, this is important. So we're going to do very quick this round of presentation of just to say hello. My name is X. I came from Ypsilon and I'm working in that. So a very round of presentation for later on. Okay.
Okay. So see you later in the new link. Okay. So as we have just 8 minutes till our career session starts, we wanted to do this small round of presentations among all of the participants. So I will ask you to just open your mic and cameras if you can, and just briefly say who you are and where you are working. So like my name is Nuria and I work at INL, and if you want your title. So I will start with Aldion Azkaraman, sorry. You can present yourself. Otherwise, we move to Arlet Marquez.
Hi, hello, everyone.
Hello.
I am Arlet Marques, and I am a PhD student in the University of Minho and at INL.
Okay, thank you. And now Mario Argotti. Yeah.
Hello.
Hello.
Sorry, I don't have a camera right now, but I'm master in nanotechnology. I'm working in a laboratory, like research of nanomedicine.
Mm-hmm. Okay, thank you.
So.
And now, let's see, Mahide Much. Sorry for the pronunciation.
Hello, my name is Mireille. I'm second year PhD student in University of Reading, and my area is food microbiology.
Okay, thank you very much. Who else do we have here? Sara Piñeiro.
Hi everyone, my name is Sara and I'm a PhD student at INL.
Okay, thank you very much, Sara. Fontaine Romani.
Hello everyone, good morning. I'm Faye and I'm a PhD student at INL as well.
Okay, Vasco Martins, thank you, Fontaine. We cannot hear you. Okay.
Now?
Yeah.
Okay. So I'm Vasco. I'm a PhD student at INL in Portugal, and I'm studying food science and technology and nutrition.
Mm-hmm. Thank you. Andrei Ipatov. Can you briefly introduce yourself? Or maybe Pablo, that you're already with the camera on.
Hi, I'm Pablo Fuciños, working on the food processing and nutrition group at INL. I'm doing research mainly on food improvement through encapsulation and 3D printing and in food packaging.
And now, Adelino Correa, would you like to introduce yourself? We cannot hear you or see you now, just briefly, sorry. Okay, so then we move to Isabel Rodriguez.
Good morning, everyone. My name is Isabel Rodriguez and I work in Lorenzo Pastrana's group. And my current project focuses on how nanotechnology can modulate the gut-brain axis regulation. So it's focusing on obesity regulation.
Thank you, Isabel. Hugo Oliveira.
Sorry, Nuria, just a second. I was okay now. Okay, good morning to everyone. My name is Hugo Oliveira. I'm a staff researcher at INL, and I'm currently working on developing of sensors for agri-food and environmental applications. So I have a background in analytical chemistry, and this is currently my research area.
Okay.
Thank you.
Thank you. We also have Mohamed Ali Wadene.
Good morning to everyone. I'm Mohamed Ali Wadene, second year of PhD at the University of Catholic University of Sacred Heart in Italy, and I'm working on the plant pathology area. And my project focusing on how to mitigate the aflatoxin contamination in maize crop.
Okay. Thank you. And Fabio Loureiro.
Yes. Hello, everyone. My name is Fabio Loureiro. I am a master's student in University of Minho. Currently, I'm making my master thesis in the food processing group at INL. And yeah, thank you.
Thank you, Fabio. Aldion, I see that you can now show your camera.
Hi everyone. I'm Aldion from University of Reading. I'm a PhD student in Food and Nutrition Department. My current project is now on valorization of food waste, focused on whey meats. Nice to see you.
Thank you. João Piteira.
Hi, my name is João Piteira. I'm heading the system engineering group at INL. We have a background in electronics, the group, and we developed activities related to IoT applications.
Okay, thank you. And finally, Alar.
Hello, everyone. My name is Ala Reinla. I am staff researcher at INL, working mostly in area related to medical devices, microfluidics, sensors. Thank you very much. Nice to meet you, everyone.
Thank you. Anyone else missing before we start with the presentation? Okay, so it is 11 now. We can start with the career sessions as we had planned. I will just show my screen briefly to introduce you to the speakers. So on this session, one second. So on this session, we will count with 4 partners of the Trusted Project. First one that we have is Lan van Wassenaer, who is a strategic senior scientist at Wageningen Economic and Research, and will be talking about blockchain in the human capital agenda in the Netherlands. Then Patrick Ruch from IBM Research, a research staff researcher, will be speaking about career paths at IBM. And then we will also count again with Mireille van Hilten and Marta Prado from the group, from the INL group, Food Quality and Safety, that will participate in a little panel session that we will do with some questions about career. So Patrick, would you be able to start first before Lan?
Sure, no problem, Nuria.
Okay, perfect. Let me just. Sure.
So can I share my screen?
Let me see if I need to allow you, but in principle, it seems that
I think
you
I can.
Yeah.
Okay, can you see it?
Yeah, perfect.
Great. So, hello again, everybody. Great to meet you and great to see a range of different research maturity levels here in this call. So from master students, PhD students to staff scientists and group leaders. I think it's great to have such a diverse audience, especially when it comes to the topic of careers, because this is something that you never stop thinking about. You should be, as my boss says, every morning you wake up, you should ask yourself, why am I working? Why am I going to work? And I'd like to spend some time here, maybe the next 15 to 20 minutes, talking about careers at IBM Research in particular. What's maybe special about this kind of research institution is that we are, of course, embedded in a for-profit organization. So how can such a research organization be structured to meet the needs of the company with respect to growth and innovation, while still maintaining, a scientific mission? So I hope I'll be able to shed some light on that in our discussion. So can I ask you, do you see a green sort of square on top of the slides? Or is it just on my screen?
We are seeing cut the slide. It's not full screen size, I guess. Some problem on the layout.
Let me.
Yeah, now it's okay.
Let me try again. How's this? Okay, thanks. Yeah. Thanks, Hugo. So I'd like to start with a question to the participants here. So I'm curious, and I'd like to ask you what you associate with the name IBM. So please just type your thoughts in the chat. There are no right or wrong answers. I'm just curious what you associate with this name. And if you have a few minutes at the end of my presentation, we'll come back to it. I'm interested to read your thoughts. So you can just use the Zoom chat if I hope that's enabled. So we'll be able to review that together later. So IBM is an enterprise technology company, right? So it's 110 years old, and it's been able to sustain this long period of existence by continuously shifting focus in the realm of technology. The mission has always been to help other businesses do their work better. And this is the overall, basically the bottom line mission of IBM. So it's a global company, right? We're present in over 90% of the countries in the world. And between, it says here, more than 350,000 IBMers. Focus is on topics that are, of course, technology driven. So AI for business, hybrid cloud. So how do you make best use of public cloud resources as well as your own private cloud resources, and how do you make sure your applications can run continuously across them? Enterprise systems and services, security, quantum computing, and all of this underpinned by a long sustained track record of innovation. Maybe the most easily measurable metric is the number of years in which IBM has received the most US patents granted. So it's now 28 years running that IBM holds that position. So you can understand that research is a very important part then of IBM's DNA, being able to sustain continued innovation over this long period of time. And this chart shows sort of a historical timeline of major achievements in the history of IBM research. So I'm not going to read all the individual entries, but you can see that they span from innovations and in terms of software, so databases, but also to very material science related topics like photoresists, copper electroplating for interconnect wiring, more recently things around quantum computing, debating, and Jeopardy, winning the game show Jeopardy. So that's possible by having a broad research organization. So a research organization that is broad both in terms of the geolocations. So the organization counts about 3,000 researchers. We celebrated the 75th anniversary of IBM Research last year. So it was founded in 1945. And some of the awards that are listed on this chart are testimony to the fundamental research that is also carried out in this organization. So there are Nobel Prizes in physics. There are medals of technology, national medals of science, and Turing Awards in the area of information technology. So the mission of IBM is then, of IBM Research, is twofold. It's one, to be the organic growth engine for the company, for IBM. So to innovate the existing portfolio and also incubate new technologies. But it's also a bold science agenda. So to make big bets on science topics that may be the source of differentiation and practical product innovation in the long term. And this is done across a range of disciplines. So some of them are listed here. The most important ones are artificial intelligence, cloud computing, quantum computing, but also research into physical sciences, life sciences, mathematical sciences as the underpinnings of these technologies. So you can imagine that there are very different researcher technical backgrounds that are required to address these different disciplines and also to synergistically integrate them. At the same time, there is one common structure within which the researchers then evolve their careers within IBM Research. And that's the topic of today's presentation. By the way, if you're interested to learn more about these historical achievements, something I felt was done very well was when IBM turned 100. They came up with 100 icons of progress, each of them representing a key innovation for IBM or for society in general. And so each of these icons can be explored online if you're interested in sort of a travel down memory lane regarding some of these technology innovations. So now let's get into the kind of the roles and career paths at IBM Research. Now, it's drawn here as kind of a pyramid structure, but I want to emphasize that this is this is kind of a fluent arrangement between different roles. And by that, I mean, you can move laterally, you can move up or down. we may differentiate two main tracks within IBM Research. So there's the technical track and the management track. Management track meaning, simply put, that you have responsibility for other people. This is not required to develop your professional career. So it's possible to remain within a technical track and achieve, a very high level of accomplishment without having people responsibility. So let me walk you through this slide. The left-hand side shows the technical track, and there is kind of a researcher track that, if you want, in principle, it can start already at the level of the student, of a master's student, of a research intern, eventually maybe a PhD thesis carried out within IBM, something that we call pre-doc, so before your doctoral thesis, or a postdoc after your doctoral thesis. So these are temporary positions that are intended to be academically aligned to the positions you have at, for example, universities. And the other part of the technical track are the development and engineering tracks. So these are then less researcher focused, but more developer focused. So think of software engineers, or think of mechanical engineers that are concentrated, for example, on so not leading research projects, but on developing new designs or new hardware implementations. So these two parts of the technical track have a certain evolution in terms of seniority and maturity. So the permanent position at IBM Research, if you're a researcher, is called simply research staff member or research scientist. And with increasing accomplishments and sustained track record, this can be further qualified by a principal or distinguished research staff member. This is still on the level of individual contributor. For the developer engineering track, you pass through also different stages of staff developer, staff engineer, senior developer, senior engineer, a senior technical staff member. And then there are the executive positions within the technical track that are the distinguished engineer and the IBM fellow. So the IBM fellow is the top distinction within IBM, not just IBM Research. And we count, roughly about 100 active IBM fellows today out of a population of, over 350,000. So it's a very select few that obtain the IBM fellow distinction. And in these positions, because they're executive, they give a lot back to the IBM, but also IBM research community in terms of consulting the strategy, providing spokespeople for also interfacing outside of IBM, and so on. There's also the management track where you can enter at any of the levels. You don't have to have a particular technical title from the left side in order to qualify for a particular title on the right side for the management track, right? So management skills and research skills may be separate. They can be synergistic, but they don't, they are, so they're not mutually exclusive, but they don't necessarily have to overlap. So also here there are the first line manager, right, who manages a team of RSMs, of postdocs and predocs. There's the upline manager who manages the first line managers, and so far and so on, right? You have lab directors, you have vice presidents of research for entire geographies or for areas of research strategy. Then you have the general managers, and finally a small number of senior vice presidents to report directly to the CEO. So that's kind of the formal structuring of job roles within IBM Research. It doesn't yet tell you anything about career paths, right? So let me move on here. What are the expectations for a researcher within IBM Research, within this corporate research environment? And basically, the expectations have always been the same, right? So the way that they are implemented may change over time, but the expectations are the same. There is the expectation to demonstrate leadership in the terms of research directions. So to come up with new research directions, be able to incubate them, and establish dynamics on research directions in order to progress that research forward. So this can be in terms of applying for funding grants, successfully collaborating with academic institutions or other companies in order to develop proof of concepts. And also aligning the contributions, not just of the individual, but also of your peers, of other researchers in the lab where you are, but also in other labs worldwide, to amplify the impact that you can achieve. It's also our responsibility as researchers at IBM to be eminent, so to be recognized as a leader in your specific domain, and to make sure that leadership or that eminence is documented in terms of journal publications, in terms of conference talks. And it's important to be recognized by not only by your peers within IBM research, but also by the scientific community at large as being a leader in your domain. And of course, this doesn't happen within a day. This requires a sustained effort and a sustained participation in professional communities and also in scientific conferences, etc. So to engage in these activities continuously. So we have a mandate to do that, right? To establish this scientific eminence. Of course, impact is a very important criterion. So how do we define impact? So it's anything that advances the state of science overall, and or the technical capabilities that IBM can assign to its products and or services. It's also about protecting the know-how that you generate for IBM to allow freedom of action. So think about patents, right? So before you publish, you may want to consider, is this something that we should patent, to protect IBM's interests in order to commercialize some of this technology, and then share it with the community. So that's how this sustained track record of IP leadership in terms of US patents has come about, right? It's one of our impact metrics. And last but not least, developing your network. So even though you don't formally have responsibility for others, you have the responsibility to engage with your peers and teams across the world. You have to work together to improve the overall effectiveness, not just of you as an individual, but also of the overall team, and help develop others as well. And I'll come back to this a little bit later in the presentation, but help other researchers do a better job, or by sharing your knowledge, or by providing mentorship or coaching. If you have a couple of years of experience, is there something you can share? Or are you willing to help others by asking the right questions? So I'll come back to this later. So these are the expectations for a researcher, not yet covering any management responsibility, just the research activity. So you see it's multidimensional. And how do you what is the model for the researcher profession, so for the professional researcher, of how to achieve this? So it's the so-called T-shaped researcher profile, meaning that it is expected you have substantial depth in a home discipline. So if you're doing your PhD thesis, this is probably an area where you have a substantial depth, right? It's something you probably know better than your supervisor by the time that you finish your PhD. So this is your home discipline where you can exhibit a strong problem-solving skills and very high competency, right? At the same time, you shouldn't forget the bar across the T. So this relates to soft skills or experiences you gather that go beyond the technical depth. So one way in which to grow this breadth is by exposing yourself to opportunities or positions that go outside of your domain knowledge or of your focus project. And this allows you to engage in a dialogue with other domains of research, with researchers that have other home disciplines and other areas of expertise, and allows you to connect the dots. It's very important. So not just for your career progression, but also to understand the context of your own research. So it's this concept of the T-shaped researcher. Now, what I also believe is that for a career progression, it's important that you recognize that there are opportunities to develop on the job, right? And I think a great way of doing that is by looking at temporary assignments. So within IBM and IBM Research, there are a few. I'm listing just a couple on this slide to give you a flavor. So there are something you may call, technical assignments, and others that are maybe more about growing your skills, non-technical skills, right? So the first one here on the list called Power Up. This is a program which is running across our global labs where you can sign up and apply to work part-time with a technical expert in your lab or another lab on a specific challenge that is outside your core expertise. And this is a technical challenge. So here, the idea is you work a few months on a technical project, hands-on with another team, to grow your specific skills in that area and to get a better understanding of the technical challenges in a related, in another research area that is not your home discipline. And you do this without, without changing your manager, without even necessarily relocating, even though you can if desired. So a very nice way to get additional technical insight within the company. Another thing is the IBM Service Corps. So this is something which is engaging IBMers in community service. So topics around, for example, public health, around education, around society needs, which are more non-technical. So you would typically move to another country and work full-time for a few months on such a, let's say, charitable or non-profit project. And this is intended also, again, to, in this case, grow your soft skills, right? And interpersonal skills, and also increase your understanding of these types of needs outside of your technical domain. There's the technical assistant or executive assistant position where you can apply to support a research executive, such as a vice president, in the technical strategy and planning and implementation of that strategy. This is also kind of a rotation that typically would last 1 to 2 years, which also gives you a broad view of the research operations. After which you can return to your research, maybe in an expanded role, or also grow your network to identify new career opportunities, again, on the job. IBM Research has this vehicle called Global Technology Outlook. Once a year, IBM Research brainstorms. So all 3,000 scientists of IBM Research brainstorm in a structured fashion to come up with research directions for the future. Some of this so-called GTO is then externalized and shared with the public. Others is kept internal as a way to inform the research strategy. And you can apply to become a co-lead of this GTO, meaning that you're engaged then for up to a year in communicating and pulling in ideas from all across the organization, and in the end, help formulate this GTO, right? Which can be a great way, again, to grow your network, but also experience how it is to shape a forward-looking strategy for IBM Research, which is also exposed to the CEO, by the way. And finally, as you may imagine, for an international organization, there are international assignments where you get the opportunity to work in different locations, other labs, for a few months to a few years to help shape the local research strategy and drive execution, and bring in some know-how that you have gathered from your home location, right? And vice versa, maybe bring back to your home location some best practices from the international assignment. The point of this chart is just to show that I think on-the-job learning is important, and that for those interested, these temporary assignments can be a very nice way to expand your horizon and also immerse yourself in other learning experiences outside of your technical domain. So what I think is also very important on the job, in addition to these individual assignments, are the interactions with your peers on a level that's not purely along the reporting chain. So what I mean is beyond the manager or beyond your group colleagues, right? And we have a very, very strong concept within IBM of mentoring and coaching. In fact, there's an internal platform where you can find a coach, which is simply just another IBMer, who wants to act as a mentor, who's willing to act as a mentor for more junior employees, or let's say employees who would like to ask for help in progressing their career, right? So the difference between a mentor and a coach is basically that, you know, mentors tend to give tips and serve as role models. They may have a lot of technical experience in your domain or in the organization in which you are, and provide hints as to how to help your progression. Coaches are more focused on helping you identify where you want to get, so and help you find out what the best way for you is to achieve your objectives. So coaches are more about asking questions. Mentors maybe are more about, you know, answering questions that you may have. And so this culture of mentoring and coaching, I think, is very important in general in professional life. And within IBM, it's lived by this kind of community thinking that any IBMer, also within IBM Research, can get trained as a coach and can sign up as a coach or a mentor for other IBMers. Okay, so to wrap up this discussion, I wanted to briefly share my roughly 10-year research journey at IBM on one chart, just to show you that it's not at all a straight line, and sometimes things are not planned either. So this chart is a combination of maybe the formal evolution in blue, and then just the research projects that I've been working on alongside this evolution. So I joined IBM as a postdoctoral researcher. Initially there, I was tasked with working on a project to provide electrochemical power while at the same time cooling computer chips. So we ended up launching a microfluidic redox flow battery project and called Electronic Blood. And what I'm including on these slides are not references to scientific publications or patents, but the videos that were made publicly available, just to show how one part of our scientific mission within IBM is also to expose our research, right? So this particular video for the redox flow batteries was a BBC report where the researcher visited us in the lab, and we showed basically how our setup works and explain why we are doing it. So I've included the links if any of you are interested to follow up on these. Another project then was thermally driven heat pumps for adsorption cooling. Here, the basic idea is that you recover waste heat from data centers. We know they produce a lot of heat, which is usually wasted, but you can recover this waste heat by a certain thermodynamical process called an adsorption heat pump cycle. And we launched a research project into this to figure out what is the optimum configuration you need to best use the data center waste heat and actually convert it into useful cooling. So so both of these projects during this time, then my position changed to RSM, research staff member. A later project then was how to leverage AI to enhance chemical testing using an electronic tongue. And this is a project that is still going on today, which I'm leading as principal investigator. So also around about this time, I did this Blue Core coaching training to also try to give something back to IBMers beyond technical mentoring, but also try to act as a coach supporting others in their career ambitions. And the last sort of project I want to list here, because it also provides another flavor of the research activities that we're involved in, is the Mayflower autonomous ship. So this is a ship that will autonomously navigate from the UK to the US, so replicating the original Mayflower voyage, which took place, I think, 450 years ago. But this ship, this time around, will be fully autonomous, and it will also have some scientific equipment on board. So actually the hypertaste sensor that we developed, this electronic tongue, has been adapted and a system designed around it that the autonomous ship will actually do chemical sampling of the ocean during its autonomous voyage. And currently I'm serving as a technical assistant to our Vice President of Research in Europe and Africa. So making use of one of these assignments to broaden my horizon and gain a better understanding of our research context, basically. So this is the last chart. There are three questions that we ask ourselves to prepare for career conversations. And I think these are questions that everybody should ask themselves. How do you define success for your career? What skills and experiences do you think you will need to help you reach that goal, reach that success goal? And you will always need help, right? What help do you think you will need to make progress toward your goals, right? And who can you involve, and who can you get on your side to help you in your journey? So I wanted to share that with you, and just leave you with links to our job postings online. And with that, I think I've taken up all the speaking time. But if we do have opportunity for 1 or 2 questions, Nuria, I think we can try to take them. So let me stop sharing. And while I wait for your questions, I'm going to check the chat to see what you associate with IBM. So thanks a lot for your attention.
Thanks, Patrick. Very inspiring. So any questions? Just feel free to open your mic and ask.
Hi, Patrick.
Hi.
Thank you for your presentations. Yeah. I would like to ask a question. Is there any researchers in the IBM that change their research focus from their PhD, and when they work in the IBM, they like shift their research focus after that? Thank you.
Yes, so this is very common, right? So especially for people who stay with IBM research for a long time, the chances are very high that there will be some transformation, right? Or let's say expansion of the skill set. So of course you never forget or erase what you did during your PhD, but I think you add on to that experience, right? So we have examples of that. There are quite extreme examples, of people who maybe entered as material scientists and a few years later found themselves, designing very large, very large integrated circuits. But it's so I think it's important to recognize that you have that opportunity, and I think it's important to continue to develop. Nobody forces you to change, of course, right? So if your objective is very clear, I think it becomes very clear, sort of, it helps you understand what you need to do to achieve that objective. And so if that means staying within one domain, that should also be that should also inform your career choices.
Thank you.
Thanks for the question. So and thanks a lot for the inputs in the chat, right? So this is so I see the IBM PC, I see timekeeping at Wimbledon, and I think that's part of IBM's so especially the IBM PC, right? And Wimbledon, these are examples of connecting to the public. And behind the scenes, it's always a bit more tricky, right? To be recognized because we're mostly serving enterprises. Yeah, so I think that's part of the reason why we're also exposing a lot of our research, trying to expose that through many public channels as well, like YouTube videos, or being open for interviews, from for example the BBC or other news organizations to share what we're doing. So thanks a lot for sharing that. I think in the interest of time, we need to move on in the agenda.
Yes, if you have any other questions, then we can maybe ask later on at the end, if we still have time. So now we will have the presentation of Wassenaer. She will explain us a little bit what's the human capital agenda in the Netherlands for blockchain. Lan, are you already here? Yes, I can see you.
Yes. Good morning, good afternoon, everyone. Sorry for my technical problems. I have to speak to you behind my picture instead of a video. And I also need to ask Nuria to share the slides for me, if you'd be so kind.
Yeah, just
yes.
1 second.
So thank you very much for joining this session. And I thank you also very much, Patrick, for your excellent introduction to the career path at IBM. So I think I'm going to switch to a different angle. I would like to start telling you a bit about blockchain research, and especially a bit about non-profit career paths in a non-profit research organization. I think that does differ a bit from our organization, which is Wageningen Economic Research and IBM Research. Next slide, please. And so I and also my colleague Mireille from Hilten, we work at Wageningen Economic Research, which is part of a larger research and education institution, Wageningen University and Research. So if you check out websites, you will also find some interesting job openings. Do check it out. And I think a little bit about myself before I later switch to a career path. I had educational background in environmental biology and later in agriculture economics. So you see, none of them has anything to do with blockchain. But so it's a later, following a different research path than I originally had planned, and as most academic paths look like. The next slide, please. You in the introduction, Nuria just mentioned that I'm going to introduce a bit about human capital agenda. Actually, my talk is not about human capital agenda per se. It is I was inspired by the human capital agenda idea that was developed by the Dutch Blockchain Coalition about 4 years ago. The idea behind is that for any new technology, you really need new talent and new expertise to help the technology to be applied. And the current situation at the time when the human capital agenda was developed, and also still now, is that there's still quite limited expertise and talent on blockchain research, which also explains why we have this research project to jointly develop research and innovation roadmap. And furthermore, blockchain is a quite broad topic. It's may require different competences, and also depends on the domain in which the technology will be applied. You may require very different set of competences. And of course, there are a lot of online resources and knowledge bases that you could use, but still there is a need for jointly develop sort of human capital for further development of blockchain for any application areas. And so in my talk, I would like to introduce a bit about the knowledge and educational topics, and also the skills and trainings that are relevant for blockchain research. But of course, I would like to start a bit with a short introduction to blockchain research. Next slide, please. Next, yes. So perhaps you have received some background information. Blockchain is not really a single technology. If you look at the technology itself, it has several layers. We call it technology stack. I believe in Patrick's talk, you also see a technology stack. Well, to put it in a broader terms, the technology blockchain has impact on many layers of the whole technological solution. And you can think of at interface with users, but also underline every user face interface. You have data and models, and also you need physical connections to enable different systems to be connected. So the next slide, please. And that is also why that we already from the beginning of this project realized that we need to look at blockchain research and the competence needs at different levels or different domains or areas, depends how you put it. You see in this Trust Eat project, I believe from the earlier introduction, you have seen the slides. We look at application areas, a physical layer, and also the digital layer. And from our institute, we focus more on application area and a little bit on the digital layer, and IBM is very much leading on the physical layer and the digital layer as well. So I would like to give you a broad overview of the competencies related to this different layer or different areas. And I summarize it actually into, depending on the focus of blockchain research and related to the three layers. First of all, you can see there are many disciplines that are relevant to have to perform blockchain research on the application layer, or in order to realize a blockchain application, you will need quite some knowledge and competence in economics and management and business administration, but also on operations research. And not to forget, there's also a lot of domain-specific knowledge required, depending on which domain blockchain will be applied. So in agriculture, obviously, you would need knowledge on agronomy and also other related domain knowledge. And on the digital layer, generally you need skills and knowledge from disciplines such as computer science, data science, and also software engineering. In the coming days, we will introduce a bit more about more detailed topics. And the physical layer, of course, you also need understanding or knowledge from more natural sciences, engineering perspective, for example, agronomy or logistics. And next slide, please. But how to look at the required competence and knowledge if you are interested in blockchain application or research. I think it may help to look at the playing fields of blockchain application. What we have noticed in our own research, but also from literature, is that it covers three very different knowledge or competence areas. To start with, blockchain is basically information technology. So you have a lot of disciplines or skills that are required to have to apply this technology. And then you also need to understand how data science fits in this in the IT process, because any software system must have input and outputs in order to be useful in any practical area. So data science is very relevant. And then we need a blockchain application eventually to solve real life problems, and almost all problems have an economic components. And in this specific case of blockchain application, it's a lot about a new upcoming research field that's called data economy. That's about how to use data to make our economy work better. So all these terms we will introduce later in the coming days. Next slide, please. So to summarize, I think to perform blockchain research, we need for the human capital agenda or human capital development, competence in IT development, in data science, and also on data economy. And we provided in earlier slides the specific topics on the specific domains and lines of work. But I think this just gives you a broad overview of the general competencies that are needed or relevant. Next slide, please. But to summarize a bit, I think what is very important to do blockchain research, it very much depends on what the problem is and what kind of research purpose or type of research would be carried out. And I also like to refer to earlier talk, one slide by Patrick. I think it's eventually for a personal or individual research group, it's important to find optimal match between personal values, competencies, and societal challenges. And I think that holds for both individual researchers and also for research groups or research institutes. From our institute, we look at blockchain from our mission of developing a sustainable agriculture and food systems. So that is our focus. And in other areas, I think most important things to consider are, first of all, what kind of problem would you like to address? What is the status quo, and what are the alternatives other than blockchain? And who are the stakeholders involved, and what is the purpose of the research? I can imagine not all of you are doing applied research, so academic research may have very different purpose from more applied research, which is more focused on delivering solutions rather than more scientific fundamental knowledge. And not to forget is also where the funding would come from. And obviously, if the funding is from more fundamental research, and the research setup would be very different, and it would require different competencies than more applied research projects. And then look at existing capacities, think of human capital, but also labs and other resources. So I think this is a very broad overview about blockchain research. And I would also like to continue a bit with, well, at least a little bit experience and introduction to the career path of our institution, so this in Wageningen. And as I introduced, we are a non-profit research institute. So our setup is quite different from IBM research, although there are some overlaps in terms of areas of impact. So I didn't include all career paths in our institution, but I think it's good to give you an overview that our research path very much depends on the area of impact that a researcher would like to have. So broadly, we have 3 areas of impact that we as researcher could strive for. So that's scientific excellence and policy impact and business excellence. Scientific excellence is focused on developing state-of-the-art methodology and knowledge that could be further applied in our areas of interest. So, and policy impact is really about influencing stakeholders, public and private, in assisting or sometimes influencing their strategy to improve their strategy or achieving desired societal impact. And business excellence in our case is not about realizing commercial values, but more about performing, acquiring interesting research projects. Of course, we do make profits on some projects, but the intention is to be able to develop more research to make sure that our research projects are also relevant to practice. And career-wise, from the scientific excellence, usually we start with a researcher as scientific researcher. So that is generally researcher with at least a master or preferably a PhD degree, so that they, in their research, they not only focus on finding the solution, but also on delivering scientific knowledge that can be further applied. And when a scientific researcher has developed his own research theory and methodology and publications, the next level would be a senior scientist, in which he can actively acquire or develop new research lines. And we also have a so-called strategic senior scientist. That's a scientist researcher who can also actively develop new research agenda. So in my case, that was my role. It's my role. You could start a research project on blockchain, which is relatively new, but strategically important. So that is considered as a role for a strategic senior scientist at our institute. And the highest level we can achieve at our institute is called chief scientist. So in our institute is chief economist. So our chief scientist decides on, among others, research projects that are more of investment nature. And so in general, horizon projects are part of investment projects for us, although I believe it's very different for university researchers or academic researchers. So there's a broader line of our research line science, which may be different from our counterparts at university, but is at our institute and our sister institutes, the similar line. And in terms of policy impact, we have, well, general senior researchers who can provide policy advice to our policymakers or other strategic partners, and depends on the scale of the projects. So you can have policy advice to a national or international different decision makers of different at different level, but the aim always aim to achieve policy impact that to support policy making at least national or a sector on a national level. But I want to also mention that in our institutes, every researcher basically has three types of responsibilities in varying degrees. So we all perform research, and to a certain extent also acquisition, meaning acquiring new research opportunities, so both from public and private sources, and then also a bit of project management. And then depending on personal interest and capabilities, we specialize further. So some are really doing mainly research, but some can also perform more project management work, or we have also colleagues who are more working on acquisition. So for colleagues who work on acquisition, the next line would be mainly focused on business development. So it's about developing new business propositions for our partners. So there we also have a chief colleague who's in charge of business development. That's really about in what area are we going to acquire new research projects and funding, and whether we should invest in developing new capacities. So that being said, you see that it's very flexible. There's no predefined routes or paths for any individual researcher to go through. So it's really a very flexible career path. And in the choices of different paths, we have quite some support from our organization in terms of education, training, and development, which you will see in the next slide. Next slide, please. So we have, besides training on the job and coaching and feedback from our direct line management or senior colleagues in the same line, we also have quite a rich repository of different trainings, courses, and also other trajectory in which people can choose to develop themselves. This is our intranet page in which we could choose different courses based on our interests, and we have quite high degree of freedom to choose, decide which competence, which path we would want to develop ourselves further on. So I think this gives you an overview of how career paths are chosen and also taken, but also what are the possibilities within a non-profit research institute as ours. Of course, this is very there's a lot of information just to give you an impression of how what the possibilities are. If you would like to know more, please feel free to let me know and in the chat, or I would also be happy to take questions. Thank you, Nuria. I think that's
Thank you, Len. Yes, I was trying to unmute myself. Thank you very much, Len, for this very interesting presentation and to know a little bit more how you work at Wageningen too. So anyone has any questions regarding Len's presentation? Okay. So now, if you can think about any, you can ask at the end too. Now we are moving to the last part. We are just running a little bit late. And the last part consists on a panel session where I will be asking Mireille, Marta, Prado, Patrick, and Lan some questions. So the first one is why blockchain is interesting for your research work. And I would like to ask Patrick first.
Okay, so one of the charts I showed was related to sensing. And if you paid very close attention, you can see that the sensor was kind of a handheld device that could be used in the field. So one issue with having sensors distributed in the field is that how can you trust them? And how can you make use of the data they produce within a trusted network? And so I think that's where blockchain comes into it. I myself personally, I'm more looking at the interface, so between the sensor and let's say a blockchain network rather than within the blockchain. So I would say the relevance comes from this need to have a trusted place to put the data, but also to investigate mechanisms by which we can be sure that both the device sending the data as well as the data it is sending can be trusted. So that's how blockchain is relevant to the research I'm currently engaged in.
Okay, thank you. And what about you, Marta?
Hello everybody. So thank you, Nuria. What I would say in my case, for those who don't know me, I'm leading the Food Quality and Safety Research Group at the INL. So the type of work that we do is to develop miniaturized devices that can be used in different points of the food value chain. So my answer will be a bit on line with what Patrick and Lan before was mentioning. So one thing is that we are developing these devices. One important thing is to know that the analysis that is being done is actually trustable. And also, the point is that we are working in the food value chain, so the devices are expected to be used in the different points of the food value chain. So this will be a big asset for authenticity, safety of the food value chains, and of course, traceability. And blockchain can bring this traceability, can help us to connect the devices that we are developing and the analysis that we are performing to broader system such as blockchain. And this for us is of course very, very important. And also I think that we are not, as scientists, we are not anymore close in our specific field of work. We need to be open-minded, we need to be interacting with other groups and other researchers from different background, and this is very important, and blockchain comes in as a natural let's say, field for us.
Thank you, Marta. So now I have another question, this time for Mireille. We have been seeing in the presentation of Lan some of the competencies needed for blockchain. I would like to know if you can explain us any others, or you think that there are other competencies or sub-competencies that we need for it.
Well, they were very complete, of course, from the topics, all the topics that you can research perspective. In general, I would say it is important to have a certain extent of knowledge on the technical side. I think there's always a discussion when we talk about project managers. Do you need a project manager that's very good at managing projects, or do you need a project manager that also knows a little bit more about the technical side of an IT project? And my belief is very strongly that it's the latter. Although you can have very good project managers that know nothing about technology or IT systems, I think it's preferably the case that when you're involved in these types of projects, it's not just researching fundamentally for my career at least. So I'm very much on the applied side of things. So how do these types of IT projects, how are these performed in real life scenarios, and how do they work? What do the users think? Are they accepting these new technologies? Are farmers going to work with a blockchain interface on their smartphone or not? So what kind of resistance and change management perspectives go alongside with these IT projects? So for me, those are very important skills as well, but they're also very general to any technology. So, but equally important. So maybe that's another addition, and also some communication skills, right? Some soft skills that can come in handy depending on your career path. So my career path was very much from coming from the private sector and coming from education. Now in research, so yeah, it depends on what you want to do, where you want to go, and where you come from.
Okay, thank you, Mireille. Anyone else would like to add some additional information for our participants?
I think so. I think Mireille made a great point about the project manager discussion. So I think domain knowledge has never harmed anybody, right? So it helps, I think, to have the domain knowledge also when you're managing a project. But I think it's important to have the roles have to be very clear, right? So project manager has to then also appreciate that his or her role is to lead the project and not micromanage the technical details, right? So I think this clarity is super important. Yeah, as you said, Mireille, I fully agree. Like having additional technical understanding helps, right? As long as you don't get too much involved with the lower level details.
Yeah, that's the downside. You have these multiple hats to put on, but you have to take them off when you switch roles, and that's difficult sometimes. Yeah, I agree.
Yeah, I don't know if we can do a sort of parallelism with. So I remember that many years ago, so people that were working in life sciences start to learn about statistic and experimental design. And this is something, the experimental design, that was incorporated in the life sciences step by step during these 20 years as a tool for performing experiments in life sciences. I don't know if blockchain could be in an extent the same process, like a tool that we're going to use for experimentalists to have I don't know, traceability or a record of the experiment, so to do more to be more confident in doing experiments, mostly in this kind of experiments that require a collaboration or a share of data among different partners.
So your question is if we should have something like that?
Yeah.
I think that would be beneficial, but I think the difficulty lies in the complexity of blockchain technology and of applying the technology, because it's always this ecosystem of stakeholders. It's difficult to build like a one-size-fits-all approach, I would say. Yeah, so I don't have any clearer ideas on that.
Mm-hmm. Okay.
Would be good to have like some guidelines for researchers. Okay, you're going to start on a blockchain project. This is what you do, but I don't think it's that evident yet, and maybe we're still too fresh into it. We need to have some more experience as a within the entire research field to come up with these guidelines.
Yeah. Could I add a bit? Sorry, I'm still behind my pictures. I think in terms of soft competency, perhaps one important competence is curiosity, I think, and willing to experiment and explore, because it's very much different. And I can imagine that words may sound so foreign that you don't want to look into it. But I think it's important to not be discouraged by technical terms and look into it and find connections to your own field. If that makes any sense.
Yes.
Makes perfect sense to me. That's what happened to me. Blockchain is still to some extent, it's still kind of diffuse. Sometimes it's still not super clear. It's quite a vast topic, I think, and you can apply it to so many industries. So it's a never-ending story. So if you're curious, you can start unraveling some of it, and I think it helps to think about. That's why we talk about use cases all the time, because it helps to clarify the benefits of blockchain once you start talking and thinking about an actual implementation or application in a certain scenario.
Nice. Any other questions that the audience would like to ask, or any comments to what we are discussing? Okay, no more. You are maybe hungry. So maybe we can finish here for today for all of our participants. Then I would like just to highlight that in the afternoon at 2 Portuguese time, we have a meeting just to let you know a little bit how the tutoring will work. So those that would like to have, those from INL that would like to have an individual meeting with any of the speakers that you have listened to today, feel free to attend, because then we will let you know a little bit how it will work. We have also sent you a form, so in case that you're interested in this tutoring, you will need to complete, and we will need to have it ready by today to plan for the next days. So that was all for all of us today. So thank you very much to all of our speakers today for your time and for the nice presentations. And we see each other tomorrow at all of us at 9 for the application layer day. Thank you very much. Bye-bye.
Bye.
Thank you. Goodbye.
Thank you. Bye.
Thank you. Bye.
Bye. Bye.
Bye.
Bye.